All right, so I felt like I was cheating you guys because I only had two videos for this set of notes. So I'm creating another problem that might be a little bit more challenging. Okay, some simple functions, but let's kind of put everything together about cylindrical shells that we've done so far. So we have a function f of x equals x squared and another function g of x equals x plus 2. And we want to rotate that around y equals -5. We want to find the volume created by rotating the area bounded by those two graphs around y equals -5. So let's draw ourselves a picture. Again, you can go to Desmos if you want to do that, but this should be simple enough to do without. We have a parabola. We have the graph of x plus 2. Looks something like that. We need to find out what that point is right there. And so, again, you can go Desmos or you can just set these equal to each other. I'm going to do it the old-fashioned way. Solve it by factoring. And so we're going to end up with x minus 2 times x plus 1 equals 0. So x equals 2 and x equals -1. We're also bounded by the y-axis too, so we don't care about what's on the left of the y-axis. All right, so this is the point 2. Well, if we plug that back into either one of these other functions, we're going to get that the y value is 4. All right, so next thing that we want to think about is now that we've got it set up, what are we rotating it about? We are rotating it around y equals -5. That is a horizontal line, which means that our rectangle has to be parallel to it. And ooh, my rectangle is horizontal. That means I need to do this where x is a function of y. So I have to convert my functions to functions of y. Not that big of a deal. All right, so first of all, y is equal to x squared. So we have y is equal to x squared. So x will be the square root of y. We're just going to consider the positive square root. And then we had y was equal to x plus 2. So x is equal to y minus 2. So there's our two functions. So when we look at the graph, this would be x is equal to the square root of y. And this one would be the x equals y minus 2. All right, so we have a few things that we need to put together for this. We need to figure out what are the bounds of integration. So I'm going to have to be going back and forth on here. So my bounds, okay, well, the bounds have to be on the y-axis. So the bounds are going to be from here, from y equals 0 to y equals 4. All right, so y is less than or equal to 4, greater than or equal to 0. Next thing, what is the radius? Well, let's go back and let's take a look at the radius. The radius is going to be the distance from the rectangle to here. That is my radius. It's a distance from the axis of rotation to your rectangle. Well, this distance down here is 5. This distance here is y. So you have y plus 5. There's your radius. So the radius is y plus 5. And what is the height of the rectangle? Okay, so the height of the rectangle, let's go back to our drawing. The height of the rectangle is going to be the difference between, well, actually, this is very interesting because we're going to have to break this into two integration problems. Because where I've drawn it right here, it's the difference between this curve and y equals 0. But once we get to here, in this area and here, it's the difference between the two curves. So in case you didn't get that, let me just kind of get rid of some of this. Oh, Shoot, I'm going to redraw it down below. So we have this, and we have this. So when we are integrating over here, the height of the rectangle, height of area 1, is going to be the difference between this curve and y equals 0. Well, this curve was the square root of y, so the height is going to be the square root of y minus 0, or just the square root of y. Height in area 2, this was area 1, height in area 2 is going to be the difference between that curve and that curve. So that's going to be the square root of y minus, what did we say that was? That was y minus 2. All right. And then that, of course, is going to give us this area in here. So setting up the first integral, let's see if I got all my stuff in here. Bounds of integration are going to be, so the volume is from 0 to 4 of 2 pi times my radius, which was y plus 5, times the height, which is the square root of y, dy, plus the integral from 0 to 4 of 2 pi times y plus 5 times the square root of y minus y, I'm not going to get it all on here, plus 2. That would be this right in there. And I'm not really going to go any further with this. This would be very easy to integrate, but you're going to have to do some algebraic simplifying. I just wanted to do a problem where you kind of had a lot of things going on. And so this is one of those problems where you've got a lot of different things going on, a lot of things to think about. All right, so hope you had fun with that one.